So we'll make a start to this. I've been asked to do a tutorial on mostly internet exchange point design and what I generally see as the best guidelines I see out there from helping getting internet exchange points set up. I'm going to start from the beginning, really the beginning, from when IXs first started, going through to looking what really are some of the current best practices out there today. Okay. Excuse me. So the slides will be on the APNIC42 website at some point, and I also keep the slides on my own documentation archive as well from presentations I've done over the years. So please feel free to grab the slides from those at any point. I welcome feedback on the content. If you have any other input or output or different suggestions, be very welcome to hear those as well. Any time, I think phones in the middle if you want. But it's probably better if we keep questions to the end, and then I can handle them then. Otherwise, it's jumping up and down and climbing over chairs is probably a bit tricky. So these are the 6 bits I'm going to look at. We'll start off just looking a little bit at the background. We'll look at why we set up an exchange point. We'll look at layer 2 exchange. Of course, that's what they are. Look at some of the design considerations. We'll look at some ways of information about what's there and also scaling them. And we'll finish off about looking at things that can go wrong. What can go wrong seems to be an accumulating collection of all the mistakes that some folks try to do getting internet exchange points established. It's kind of a bit of a shame because, we've on the stuff, knowledge and so forth that's been developed over the years. So we'll look at some of those things that can go wrong as well that I haven't documented either. Okay, whoops. Right, a little bit of history. Where did it all come from? So I'm relying more on my memory, and as I get older, my memory seems to be not getting quite so good. I started in the internet industry probably, when I was at university in late 80s. I started playing with IP. I joined the UK's first commercial ISP in 1993, and that was actually a year exchange was set up. So having a little bit history of that and experience from doing that has kind of left me spending a lot of my career from then to now being involved in assisting with setting up exchange points all around the world. I think most continents I've been involved, coming in, helping, bit of advice, bit of assistance, trying to do the technical bit, trying to keep the politics out and so forth. So where did the concept come from? I'm not claiming this is exhaustive, but just to try and give you a little bit of the history from where it went. So early internet, of course, NSFNet, one big backbone, funded by the US National Science Foundation, really aiming to connect academic and research institutions to their own backbone infrastructure, but there was an acceptable use policy. Some of my early memories of internet in the UK was having to get customers to sign the NSFNet acceptable use policy, and a lot of them not really understanding why they had to do research and when they couldn't access the failures, their favorite Gopher or FTP sites, because we didn't have web back then, really. And of course, the acceptable use policy was no commercial activity. 3 network access points, Chicago, New York, San Francisco, and these were access points to access NSFNet backbone. Private companies also needed to interconnect their networks, requirement to send commercial traffic, which couldn't, of course, cross the NSFNet. So some of this to NSFNet also became interconnects for commercial traffic. Early exchanges, I mean, some of these names are long, long ago in history. KIX West, West Coast of the US, May East, and of course DGIX in Stockholm were the early ones that I remember. NSFNet came in 1995. That really introduced the commercial internet to all of us. More and more private companies selling bandwidth. ANSNet was the operator of the late NSFNet, and they were kind of forced to join the IXs as you had the separation between academic access and the commercial internet. There was a routing arbiter project way back then as well, designed to help with coordination of routing exchange between providers. Of course, a lot of you still see that in the shape of the RADB. That's the routing arbiter database. It's about the only remnant project from way back then. Some more history. The NAPs established late in the NSFNet life were some of the original exchange points as we recognize them today. But the NAP operators tend to be the big telco, the big, I suppose, service providers in the US. And so, and of course, that's one of the things we see today. It's very difficult for a service provider to run what we see or what we call an internet exchange point. So these were the early NAP operators and eventually being replaced by IXPs in their own right because the NAPs were not considered neutral. I mean, why would you connect to a Sprint NAP when Sprint was being an ISP providing IP connectivity as well as trying to interconnect commercial operators? There was the Virginia NAP replaced by May East and so forth. Mid-90s saw rapid internet growth. I mean, we all saw that. The more and more providers, more major providers connected to these early interconnects. DGIX was formed in Stockholm, 1992. 3 major providers in the Nordic countries connected there. And of course, it was done for latency reduction because the traffic always went back. Lynx was formed in London. It was the 5 UK operators interconnected there. Latency reductions, performance gains, local traffic stays local. I mean, we had the classic cases in the UK to connect between the 2 providers. At least between us and one of the other ones, traffic went via the west coast of the US. That's not most efficient from Europe, especially when bandwidth across the Atlantic was so expensive. And the latency, well, adding up the milliseconds, would probably be about 200 milliseconds to get formed in 1994. I mean, the UK operators weren't too excited about connecting the networks to each other because, of course, they're all competing. And they're all trying to knock each other out of the market. But because we weren't interconnected, nothing was really growing very much at all. Of course, as we say, the rest is history. As far as Lynx goes, it's now one of the biggest exchanges in the world. HKX, of course, in this part of the world, formed in Hong Kong. I think it was probably the first one in Asia Pac, 1995. Again, vibrant internet community, lots of local operators, and again, for latency, performance, and local traffic benefits. AM6 started in Amsterdam, not long after Lynx did, again, for the same reason, interconnecting local networks. There are probably others who've got history back to those mid-90s year, but really from these first few appearing, there were many exchange points started growing or appearing in the following years. So what is it? Well, what I've put in red is very much what I consider an internet exchange point. Neutral location, where network operators freely interconnect the networks to exchange traffic. All those are very, very important points. Neutral is very, very important. Freely is very, very important. Exchanging traffic is what these things are about. The physical IX is just an Ethernet switch. Just an Ethernet switch, nothing more. I mean, we see things over the years about IXs gaining all kinds of weird and wonderful things. It's literally an Ethernet switch provided for operators to plug into and interconnect. So the operator of the IX, whoever that may be, provides the switch and the rack space, and the network operators themselves bring routers and interconnect them via the IX fabric. So it's a very, very simple concept. any place where providers meet to exchange traffic. So anywhere where it's convenient for a group of providers to interconnect the networks ends up being your IX. It's layer 2. It's Ethernet. 100 gig all the way down to 100 meg. Are we still doing 100 meg? And I put it in. I've been deleting 10 megs from this slides now for a few years, but even 100 meg seems kind of pointless. My laptop sitting there has got a 1 gig port on it. Most simple routers these days have 1 gig. It seems to be kind of a legacy interface. So Ethernet switches, by and large, in the recent ones I've been involved in, 10 gig ports with support for 1 gig if it's required. But the interesting thing is, lots of other technologies have been used in the past. Right? We've seen IX fabrics using ATM, and we remember what that is. Frame relay, do you remember what that is? Do you even know what SRP is? Or FIDI, or SMDS? But those older and obsolete technologies have been used in the past for exchange points. And we did layer 3, and the italics are mine. Very definitely historical status now. I mean, the best known example was KIX West. I mean, I always remembered it when we were connecting to KIX West all those years ago. It was a router, what was a Cisco 7010, I think it was, in its second variation. I mean, it didn't have the memory, didn't have the CPU, didn't have the interfaces, throughput, and how it was administered was kind of really strange as well. So it was very quickly overwhelmed by the rapid growth of the internet. And so Ethernet very much now is the only way we do this. So why do we create an exchange point? And it's all about saving money, improving the quality of service, and generating a local internet economy. Those are the three most important things. So we look at the pieces. So consider a region with one service provider. Provide the connectivity for the customers. They've got 1 or 2 international connections. Internet grows, maybe another provider sets up in competition. They do the same thing, providing connectivity, have their own connections. So then how does traffic go from the customer of one provider to the customer of another provider? Of course, via the international connections. Because, of course, the 2 providers, they're competing with each other. They won't even dare think of interconnecting. Oh, no, we can't do that. They'll steal all our customers. Forgetting, of course, that the other one, well, you could steal all their customers. And so you end up with there's no local content. Content goes where it's easily accessible for both providers' customers, which is not in your country, it's in somebody else's country. And of course, you're then using your expensive international capacity for local traffic. So yeah, I mean, in some parts of the world, that's still sat 50 milliseconds, give or take, if it's geostationary. So local traffic could be taking over 1 second round trip time. International bandwidth, of course, is really expensive. Costs significantly more than domestic bandwidth. In many parts of the world, domestic bandwidth is basically free. If you can run fiber from A to B, it's just cost you the cost of putting the fiber in place. And of course, the international bandwidth becomes congested with whatever local traffic there is. That costs you money. You've got money, net money going overseas, paying some other foreign operator, an infrastructure provider, just so you can send traffic locally. And of course, it harms performance. We all know that longer round trip times means slower transfer rates and so forth. So the solution is really that the two competing providers peer with each other. And for all my work over the years, trying to get 2 competitors to interconnect their networks seems to be a really, really hard thing to do. Usually more at the management level, where the management simply has no buy-in. They live in this deluded world that they can somehow knock out their competitor and be the sole operator. It just doesn't happen anywhere at all, at least not without intervention. So if they interconnect with each other, both of them save money, local traffic stays local, better network performance, better quality of service, more international bandwidth for expensive international traffic, and the customers become happier. I wouldn't say there's more international bandwidth for international traffic, because what happens, because the network ends up being quicker because the interconnect was set up, some of us thought, well, it will save our expensive international capacity. I think we saw a dip for 2-3 weeks, and then our international capacity filled up again because everything else got quicker. It was about 2-3 weeks. What about a third provider entering the equation? Becomes a significant player as well. Same story, local international traffic goes over the international connections. They agree to peer with other two providers to save money, keep local traffic local, improve network performance, QoS. Now, you could run private links between each one. You could do that. But that means you've got to buy connectivity between to the other two providers. So, you probably could do that. You're buying 2 half links. If you share the cost of the link between the two of you, you're buying 2 halves, which makes 1 whole. But what about 4th one or 5th one, and so on and so forth? A growing internet economy means the more network operators present. So adding more doesn't scale. And so the only solution is an internet exchange point to help make all this peering scale. Whoops. It's to buy just 1 whole circuit connection from their premises to wherever the internet exchange point is located. So rather than n-1 half circuits to connect to the n-1 other providers. So 5 providers have to buy 4 half circuits, which is 2. So it's really twice the cost of the connection to the exchange point. So this makes it scale much, much more easily. All right, so the solution for this is every provider then participates in the exchange point. The cost is minimal. You've got 1 local circuit providing all your domestic traffic. International circuits are used just for international traffic. And of course, if you lose the connection to the IX, then your international connectivity will give you backup to connect to the other local providers. But suddenly, by the time you're relying on the exchange point, you really do not want local connectivity to fail. And you don't want the local exchange point to fail because it becomes quite critical to the local internet economy. So the result of all this is that local traffic, because generally if you've got access to fiber and able to lay fiber from your network to the IX, you run it as fast as you can. 10 gig SFPs are now very, very cheap. Almost the same price as the 1 gig SFPs. Why bother run fiber at 1 gig when you can run it at 10 gig? So round trip times, it's okay, sub 10 milliseconds. I was being very, very generous. Maybe you're talking about milliseconds. Internet experience, because the local performance, local traffic, local content is very, very available. And it encourages content providers. Yeah, we do this internet thing for content, right? Your end users are looking for content. It means content providers now can host content locally. They no longer need to plant it in some overseas data center or wherever. It becomes cheaper and faster for them to put all this in locally. So you get your own local internet economy. We saw that in the UK within a year of the links being set up. I mean, the local internet economy in the UK just grew so fast. Okay, we were helped by deregulation of European telecoms and Microsoft putting the data center, European data center in the UK and so forth. But they could do that because we had the exchange point and ready access to all the operators in the UK. That kind of thing becomes very, very attractive for the content providers. Who can join? Well, the requirements are very simple. Any organization which operates their own network, has their own address space, own AS number, and their own transit arrangements. Pretty simple. Any operator. It always dismays me that some IXs come up with all these rules and regulations about who can and cannot join. Right? There should not be, must not be any rules. The only requirements are technical, operational that I've listed here. So this means it can be commercial ISPs, it can be academic and research networks. Right? They're running network infrastructure as well. Infrastructure operators come along to the exchanges. They love the exchanges. So root operators, the country top level domain will show up. Because again, having a root name server or any of the country name servers right there at the IX means they have very, very instant access to all the participants of the IX. quicker DNS lookups means an end user has a much better internet experience. You're not waiting for some overseas name providers, of course, get access to their end users very, very quickly over the IX fabric. The broadcasters love being there as well. Okay, content providers also. They love being there, again, for those reasons. So it becomes very, very attractive for many operators to participate. In quite a few places, e-government is quite important now. Access to resources online. You don't have to queue at various help centers or whatever else to get paperwork or fill in forms or apply for documentation and so forth. Do it all online, readily accessible for the internet, local internet economy. So anyway, to recap, so joining an exchange point, any organization operating their own network, their own address space, own AS number, and have their own transit arrangements. That's all. When it's not beneficial, well, it's not beneficial when you're up against country legislation which says the internet is run as a monopoly. I mean, law breaking is something that's not really something we want to get involved in. So if legislation says that you will get transit from one legislated monopoly transit provider, there's not a lot you can do about it apart from try and change the government to try and change the laws. So there it doesn't work. There's some places where it doesn't make any sense. Geography. I mean, we probably don't need an exchange point if there's only one service provider serving the whole economy and we can't even sustain two operating. So, but that's very rare. Very, very rare. I can think of one place where it really doesn't make a lot of sense. So geography, well, maybe some island somewhere, probably not a lot of point doing an exchange point if there's just one service provider. So, oh gosh, this is a very, very sensitive clicker, I apologize. The places where exchange points are not permitted. Government-operated national telco, where the license mandates connecting to the national telco for internet services. And these invariably are really expensive, very expensive domestic connectivity, national connectivity offerings, and there's virtually no real domestic internet economy. It's still sad to see there's still countries in the world where network operators are not allowed to interconnect with each other. Offline, why some of the reasons are. But it's a shame that we still have situations in the world like this. Okay, so what is the actual IX? I've already talked about Ethernet switch. So it's a very simple concept. It is just an Ethernet switch. That's the interconnection media. Each network operator brings a router, whatever brings means, connects it to the Ethernet switch provided at the exchange point. Each service provider peers with other participants using a routing protocol called BCP. Right? The exchange point itself is just an Ethernet switch. It doesn't get involved in the relationship between the folks who connect into it. However, scaling this simple Ethernet switch is the challenge for the big IX. I mean, a lot of the work I do around the world, well, I don't know if you really want to be like Lynx. I mean, Lynx has, 600 plus members, or M6 or DKIX, some of the big European IXs. I mean, maybe having that ambition to have that number of members in the future is a great one to have, but we don't start building it as though they're going to be 600 members from day one. So you can get a 10 gigabit, 48 port, 10 gigabits Ethernet switch for not very much money at all. Certainly a lot less than a lot of the costs of meeting and political discussions about why we shouldn't have IXs. Right, so the design is actually very simple, Ethernet switch. We'll look at the scaling of these as we go on through the slides. It would look like this. Okay, and that's a simple diagram from years ago, but it just shows the simple concept. Ethernet switch in the middle. The service providers bring the routers, plug into the switch, and they set up peering between each other across that Ethernet switch. And the little cloud on the side there, I've just tried to draw things like what you would typically see at IXs, like the root, TLD, DNS, perhaps routing registry, looking glass, and so forth, which we'll talk about later. And of course, the exchange point itself will need a small management network, things like getting traffic stats off the exchange, support for things like looking glasses and so forth. And as things grow, maybe a second switch makes good sense to do. People realize very quickly that once the IX is there, it becomes critical infrastructure. It becomes very, very critical for the local economy because there's so much traffic going between the different providers. But quite often you put a second switch in, usually in another location, close by, or maybe another floor of the building, or even in an adjacent rack. It just depends on the local situation. Because there's a concern that if one switch disappears, so again, that's not a great diagram, but it just shows the concept of having a couple of switches in the core. So 2 switches for redundancy. The service providers use dual routers for redundancy and load sharing. And of course, the IX will have services for common good. So the members of the exchange point agree on what these services should be. Internet portals, search engines, well, whatever those are. I really need to update these slides. DNS, root servers, the top level of the main servers, maybe NTP, very, very common to see maybe a GPS receiver at the exchange point. Some of them even have atomic clocks. Atomic clock at the bottom of the rack, providing a time synchronization source for the service providers in that region. Routing registry, more unusual, but looking glass is certainly very common. Those are useful services to have provided for the membership. Very connectivity media if you can't get fiber access, but they should be able to do it without cost or regulations imposed by the location. Of course, you have the common sense things, like if you're going to be digging up roads or other access to get there, then of course there may be regulations to do with that. But it should be something that every operator has to face if there is such a thing like that. You don't want to locate the IX in one of the members because then that member has the perceived advantage over the other members because they don't have to go digging up half the town just to get access to it. So neutral location is very, very important because remember, we're connecting competing network operators together. I mean, even though the network operators compete very aggressively in the marketplace, do remember that network engineers all know each other, they all work together quite closely. No advantage by being at, say, hosting the IX and marketing the advantage of that. So certainly in the work that I've been doing over the years, emphasizing neutral location, very, very important. Secure location. I remember things over the years. I remember my first visit to May East. I don't remember when that was. I was horrified to find it was actually in a car park in Falls Church. I thought it was going to be this massive, important data to cross the street to a car park, a spare room in a car park. I was like, what's going on here? But okay, that was early days. It actually moved somewhere else. So treat it like anywhere else. Secure location, thorough security like any other network data center. Accessible location is important as well. I'm not mentioning the Auckland Peering Exchange in Auckland, but that was the classic one. Is that quite accessible way at the top of the Sky Tower in Auckland? You want something easy and convenient for all participants to get access to. Expandable location, don't want us a tiny room like the last rack in a data center, because exchange points result in internet growth and increasing space requirements. You find many places where the IXs, they're in quite big data centers with plenty of room round about, because what happens is the service providers will bring their kit in and go, ooh, this is a nice data center. I'll put some more equipment in here as well. We found that at Telehouse in London. Links was actually set up in Telehouse in London. I mean, it took quite a lot of work persuading Telehouse that they should actually host this. I mean, I remember the discussions. It's like, internet? No, that'll never catch on. No, we don't. We're a disaster recovery. And, well, you now it's like a end of no longer doing what they were actually set up to do. So even though it took a lot of persuasion, Because the exchange point was there, everybody started bringing their points of presence and other equipment in there as well. So expandable locations are actually quite important. Operation requires a neutral management. Neutrality is important when participants are represented. So the management board is generally run by all the participants. It's not like, or if it's not run by all the participants, at least the operations staff have oversight by the members. After all, it is for the members. The members are interconnecting to benefit performance and throughput between the networks. So folks who would generally run it. Funding, again, costs agreed and covered equally by the participants. If you're lucky enough that your IX is funded by somebody else, great. But generally when there's no external funding, then the membership agrees to equally cover the costs. The hosting location often contributes. I'll cover this in a bit. Because the exchange point brings them more business. I mean, certainly for data centers, I would expect that the exchange point could be provided for free because the data center wins so much business with the network operators who peer at the IX bringing in their equipment. 24/7 cover is available, provided by the hosting location, and again, managed by the consortium. In some places, this is just not available. So you kind of have to make do with the 9 to 5, Monday to Friday, and then somehow arrange access outside those hours if there's anything wrong. But you really want to get to 24/7 cover as quickly as possible so that if something does go wrong, it can be fixed quickly. Configuration, well, public address space for the exchange point LAN, I much prefer to see that. Some people try and use private address space for V4, which just makes things hard. Just makes things harder than they need to be. V4/24 gives you up to 250-ish devices on the LAN. V6/64 gives you quite a lot. So public address space for the exchange point LAN. Another thing that comes up quite a bit is like, oh, an exchange point needs an autonomous system. Just remember that an exchange point is an Ethernet switch. Ethernet switches don't need autonomous systems. They don't use BGP. The service provider connecting to the exchange point will need an autonomous system so that they can peer with the other operators. I mean, there's the usual network security considerations. Of course, the switch needs to be securely configured, like any other network equipment. The exchange point management and services routers need to be properly protected as well, public infrastructure. What else? Industry standards. Well, the European Exchange Point Association have documented various standards, at least applicable to their membership. I'm not saying that they work everywhere around the world, but this is a starting point. I mean, the folks who actually run IXs probably have a pretty good idea how to run IXs. So I'm always pointing folks towards documentation like this that's been well put together for many years. They have a BCP as well, general overview of the infrastructure, operational policies, and management of the exchange point also. All useful guidelines about if you're interested in setting up your own exchange. Okay, layer 3. This is one I hear far too often. There's no such thing as a layer 3 exchange point. It's a marketing concept used by transit providers. I'm not going to mention names, but there are quite a few well-known ones out there. They see the name of the exchange point, think, oh yeah, look, great, yeah, exchange point, big, lots of headlines. Let's call my transit business an exchange point. Or when I challenge them about it, they go, well, we're exchanging packets. Well, we're all in the business of exchanging packets, but a real internet exchange point is layer 2, open, neutral, interconnect where anybody connect. Anything else is not. Right, so layer 2 is the accepted international standard. I mean, what breaks makes the path between or via the exchange point suboptimal, even less preferred. Right? Path between peers usually remains with upstream transit provider rather than going through the layer 3 infrastructure. Members can't peer with whom they want to peer. Right? Your peering is determined by this layer 3 thing sitting in the middle. I mean, I remember back to the days of Kix West trying to get BGP sessions and trying to track somebody down who could configure the BGP so we could set up peering with other folks. Right? You have this middle person setting up, managing peering sessions and your peering policy. Doesn't work, doesn't scale, and does not make it an exchange. More complicated troubleshooting, of course. Troubleshooting peering problems has to involve the operator as well, and there's no real policy control. BGP does best path, and of course, best path is not necessarily what you want to have in some of your peering sessions. Never mind BGP attributes. BGP attributes get dropped by the router in the middle, things, communities, for example, meds, and so forth. It's just generally bad all around. So if you're thinking about exchanges, layer 3 ain't in any shape or form. It's layer 2 is what you want to do. Cheap, simple, easy to get going. Of course, the content providers won't join it. They tend to prefer to peer directly with the exchange point members. They're not going to peer with some router run by some whatever on the off chance they might get access to the membership. So this is just bad. Redundancy problems, you're basically setting up a transit provider. So the providing redundancy ends up being a transit provider redundancy and not a neutral IX. And of course, the operator needs strong BGP skills, probably better BGP skills than anybody else has. And you don't really want this either. It's not justification for running at layer 3. All right, so I think I've made this point already. The core is an Ethernet switch. Managed switch, no unmanaged switches, please. It has to be a managed switch. Must have a reasonable security features. Years ago, it was the Exchange Point Working Group at RIPE started a switch wish list. This got transferred over to URX a few years ago. I mean, okay, it's a wish list. It's the perfect switch that a vendor could build. But it also contains a lot of useful info about ideally what a switch should contain. And it superseded all other types of network devices for an exchange point, right? So Ethernet switch, right? You can get nice small 12 or 24, 10-100. Why bother with 10-100? In these days, as I was saying earlier, we're very much now gigabit Ethernet, 1 or 10 gigabit Ethernet. You can get those for a couple of $1,000. Very simple to get going. I mean, I guess I'm talking history here. But nowadays, we see Ethernet switches, 10 gig, 40 gig Ethernet, 100 gig Ethernet. 100 gig Ethernet is still expensive, but the places where these are starting to become necessary. Each provider brings a router. You don't have to physically bring the router these days because the increased availability of fiber, service providers can connect directly to the IX from their location, which is probably close by, without having to provision the dedicated router at the physical IX location. What we were trying to avoid in the early years was service providers bridging the exchange point Ethernet back to the LAN, their POP LAN in their own office, which just was generally bad all around. But I mean, these days, again, the standard is for the service provider to bring their own router to IX. But quite often now, maybe the service providers in the neighboring building, or maybe in a different floor of the data center, so running fiber between the two is very practical. The router doesn't need much either. Again, it dismays me quite often to see some IXs set up where the providers come along with like an 8-slot big chassis router, and you've got one Ethernet interface going to the switch, and one Ethernet interface going back to the main network. And it's like, what do all the other slots do? Oh, well, just in case we're going to expand. What exactly are you going to expand into? You need one Ethernet port to connect to the switch, and then another WAN port, whatever that may be, to connect back to the service provider backbone. So, common mid-size IXs, I see a lot of 1RU routers with 10 gig Ethernet ports. I mean, the typical Cisco Juniper brands and others as well. that can do that, and they're not slot devices. 1 rack unit, 2 rack unit, quite a small box. You need the throughput. You need the ability to run BGP. So possibly switch located in 1 equipment rack dedicated to the IX. You don't really want to end up with 1 big rack where everybody comes in and out with their routers. Switch maybe in the middle, you end up knocking connections and so forth, so it disrupts service for other folks. So generally try and keep 1 rack for the IX switch that nobody else can really get into. Because there'll be other IX operational equipment as well. If you get GPS receiver and you get servers maybe for the IX website and so forth, that will all start taking up a bit. Gig, 40 gig, 100 gig. Well, you can get copper 10 gig now, but that's still a little bit new. But those are the type of ways you would connect from your router into the switch itself. Whoops. Each participant needs to run BGP. You need your own AS number. Public AS number, please. Unraveling exchange points, but if you do very hard work, been there, done that way too often. Public AS numbers are readily available from APNIC to do this. I mean, there are 4 billion AS numbers, so it's not like there's a shortage. So getting an AS number for using BGP should be very easy. Each participant configures external BGP directly with other participants. Right? You can peer with everybody, if everybody wants to peer with you, or you peer with a subset. And this is the next bit I want to get into. Because again, things can go badly wrong here with too much well-meaning. So the first one, mandatory multilateral peering, does not work. Well, there's 1 exchange point where this actually works, but then everybody agrees. Only 1 that I know where this actually works. Where each participant is forced to peer with every other participant. Everybody has to peer with each other. Right? So mandatory multilateral peering is generally death of an exchange point. Where it's been tried, it's the death of the IX. IXs should not be interfering with what their members are doing, period. Multilateral peering on bigger IXs will put route servers in. In fact, all IXs these days tend to put route servers in. I'll talk about what those are in a bit. But they're the participant that has something called an open peering policy. They will peer with everybody who wants to peer with them. So that's your multilateral peering. Bilateral is what we've been doing a lot of here out during the coffee breaks. We all go talking to each other, one-to-one. Participants set up peering with each other according to their own requirements and business relationships. And that's the most common situation. So generally at an IX, you see bilateral happening between the bigger providers, multilateral happening between the smaller providers. So that's the type of peering that you would see there. And then, of course, the types of operated peering policies, you get open peering, which is I will peer with everyone. Right? So there the provider will publicly state that they'll peer with every party who approaches them. So commonly found at exchange points where the service provider participates via a route server. I'll talk about the route server in a bit. Selective peering, where they are selective. Generally, they want to meet you first. They want to talk to you, find out that you're a real person, not a computer, things like that. Right? So they'll discuss the interconnection between the networks. They'll discuss the business activities and so forth. Selective peers tend not to peer with a route server. Route server, you don't really know who you're going to get going to connect to. And then the closed peering, this is where the service provider just says, no, I'm not going to peer with anybody. Or they have very, very stringent requirements before they will peer. All right, so this is generally reserved for the biggest providers around here. So people who've got closed peering, I don't see so many of those at exchange points because they tend to do private interconnects with each other. But some places you will see providers with closed peering show up. The peering database documents providers' peering policies and contact information. Again, I encourage all operators with autonomous systems to register in peering DB. Right? You put your AS number, or want to do more peering in different places. Being in the peering DB certainly helps your peering opportunities. Okay, like anything else, peering database is just, it's an open collection of ASs and so forth, and some of the information there is quite old, but at least it can. And coming out of all this is that because many operators are present at exchange points, you end up finding out about the exchange points and the interconnects. Then you can, if you're a transit provider, you can start making efforts at finding good exchange points to participate in. Participation in peering fora is encouraged as well. I mean, of course, there's a global peering forum. There are many regional peering fora. Many countries have their peering fora as well. Of course, doing a bit of advertising for Apricot, we have a peering forum that takes place there as well. So these opportunities for providers to talk to each other in a setting like this are being provided in more and more places. As for routing, this is just, again, some general advice more for service providers connecting to exchanges. Don't carry default routes in your border router. Don't carry the full routing table on the router that connects to the exchange point, because that leaves your router open to abuse. So yes, you could probably do packet filtering. It's easier just to set up the router so it only carries the routes that the exchange point peers are offered. Some people actually offer transit across IX fabrics, which kind of makes me a little bit nervous. I mean, do your transit, which is a private relationship, on separate physical infrastructure. I mean, no exchange point can stop people doing whatever they want to do, unless they do something to the detriment of the other members. I see some IXs say, you will not sell transit across. Well, how are you going to do that? Start looking at packets? You don't want the IX to do that at all. Right? IX is, again, just the Ethernet switch. But again, some of the good practice recommendations is if you want to do privately, not across the IX fabric. What else? Yeah, again, ISP routers of the exchange try not to carry the IXP LAN around the IGP. Use next hop self if you know your next hop, the IX LAN appearing across the backbone. And so potentially we don't leak the IX address space onto the global internet. And something, again, I've seen quite a lot of people do, generating the aggregates for the service provider on the peering router. If the peering router is remote from your backbone and gets chopped from your backbone, then, well, you still announce the aggregate to the IX. But, of course, traffic from your peers can't get back to your backbone. So you end up cutting yourself off from the local internet. Again, that's some of the mistakes I've seen happen. Address space. As I said before, some folks use private address space for the exchange point LAN because they worry that, the members might leak the LAN address space out to the internet. Well, I don't really like that. There's plenty of address space. APNIC certainly has policy that an exchange point can get v4 and v6 for the physical exchange point itself. So make use of that policy. But most of the IXs I know use public addresses for the LANs. And of course, providing both v6 and v4 should be just standard. Some folks ask me, well, should we provide a different LAN for v6 and v4? And I'm kind of, well, why? What's the advantage? And there isn't any. We're running dual stack backbones across the internet today. Exchange point just sees two different ether types, one for v4 and one for v6, and can handle both just nicely. Autonomous systems, well, the exchange point itself doesn't need an AS number because it's just an Ethernet switch. Ethernet switches don't run BGP. But some exchanges have a route collector, which I'm going to talk about. Some have a route server, which I'm going to talk about. And those two do an AS number. Some IXs run common good services, so the members have defined common good services, which usually require internet transit. Even the website of the exchange point does need to be visible for the internet, marketing the IX, indicating availability, traffic stats, and so forth, which means the exchange point needs a transit router for the services, but not for the LAN itself. And of course, that router will need public AS number and public addresses. What about hardware? Yeah, I mean, switch needs to be managed, as I mentioned before. Switches with CLI access. I know some of us like just having pointy, clicky interfaces, but CLI is very important rather than just managing the thing through SNMP. Unmanaged switches means unmanageable IX. Don't even go down the path of unmanaged switches. Insist that IX participants bring a router, so connect a router to the switch. You don't want spanning tree and layer 2 security issues. I've remembered over the years some problems where service providers connected an Ethernet switch to the IX switch. Oh, well, yeah, but it does layer 3 as well. Doesn't matter. We don't want spanning tree or any other layer 2 issues. So port security, MAC filtering, again, used quite a bit around exchanges. Insisted participants bring their own router, certainly for long-haul links. A lot of Ethernet switches don't have big buffers. So you don't want to run out of buffers because you've got some long-haul link plugged into the IX switch. What about charging? In other words, costs. Right? The IXs need to be run at minimal cost to the members. So common examples, the data center hosts it for free. That's the ideal, because then it doesn't cost the exchange point anything to operate. IX operates cost recovery, very common. And some of them operate with different pricing for different ports. If you have to fund the Ethernet switch, some of the bigger switches, line cards with, say, 10 gig or 100 gig interfaces cost quite a bit different from those with 1 gig interfaces. Most of the starter IXs, say, using a 48-port 1 gig, 10 gig switch, there's no real need for differential pricing because the only differential pricing is for the optics. And the 1 gig SFP versus a 10 gig SFP plus, not much price difference at all these days. The other thing, exchanges don't charge traffic. They're a peering enabler, encouraging charging for traffic with the members. With your members, so don't charge. I think I have a slide for that. So it's the data center itself, air conditioning, technical support there, 24 hours cover, electricity. If you can get a lot of that free from the data center, then you can pretty much run the IX for free. Maybe after 3 years or 5 years, or maybe you need to plan on getting a second one at a different location. That's where the costs for the IX actually come in. And there are quite a few organizations who happily assist with trying to get the IXs upgraded and so forth. Whoops. Yeah, so where am I? All right, so here we go. This is the first example. Data center hosts the IX for free. So they cover all costs relating. They provide the switch, supporting infrastructure, operator cover, benefit from the business of the IX members, and the customers bring to the DC. And they benefit from the prestige of hosting the IX and all its services. So here's one example where the IX doesn't charge members for anything at all. Seattle IX is kind of the biggest example of free for everybody to participate, which is very, very nice to see. Next one is members pay a flat fee. This is fairly common. So here you have the cost of the switch and the ports, cost of operator support, the data center costs of power, air conditioning, and so forth, membership association, a contingency needed for new equipment and upgrade. So that cost, that annual cost, is then shared out amongst all the members. And that's pretty cheap for everybody as well. Because the cost is shared out, it's not really very much for anybody at all. And of course, the more members you get, the cheaper it becomes for everybody. Actually, the more members that you get, the bigger the switch you need and the more you can do. So it goes both ways. But members paying flat fee is probably the best and most equitable model if you can't get it for free. And some of them, well, this is NetNod in Sweden, for example, they do differential pricing. And this is the example they gave me, which is like one LAN card may handle 40 100 gig ports, or 24 10 gig ports, or 96 1 gig ports. And the costs of the cards are then shared amongst the folks who, say, connect at 1 gig, or versus connecting at 10 gig, and so on. This, again, is quite a sizable IX, and the relative port cost is passed on to participants. So again, this is a nice way of sharing around the prices. Members getting 100 gig Ethernet is actually quite expensive for the IX to handle. Services offered, of course, you don't want to compete with the members. So web hosting, I've got many, many things where the IX says, oh yeah, we want to provide this service and that service and the next service. Well, you may want to do it, but you don't have the say. It's what do your members want? And that's why the member association is very, very important. It's the members who determine what the exchange point does. So if the members all say, yeah, we're going to do web hosting here, fine. Would agree to do the hosting business rather than having their interconnect do it. Other thing, IXP operations should make performance and throughput statistics available to members. So things like the aggregate traffic on the switch, how it's doing, how the thing is scaling and so forth. Of course, you're not going to share traffic of one member with another member. That's all quite confident. Throughput at the IX, because they would want to see it as much as the public would want to see it, but how beneficial the exchange point is for the local industry. So what you see, other services offer could be root name server, very common. Any cast instances of FIL, and there are probably others as well, turn up at many, many exchange points. Right? So those root name servers turn up. I think K turns up at some places as well. Right? Having the root name servers at exchange points really benefits the redundancy and resiliency of the DNS system. ccTLD DNS, again, very common. Some of the root operators also look after ccTLDs. And so you see quite a few ccTLDs will turn up at the exchange points as well. Again, for the same reasons, to provide more redundancy of the DNS system. GTLD DNS, VeriSign amongst others, turn up at exchange points as well for the same reason. So these are very common. So route server, going to talk about in a bit, helps scale exchange points by providing easier BGP configuration and assistance for participants who have the open peering policies. And of course, there's a looking glass, which is a very handy way of, well, firstly, troubleshooting, so connectivity from the exchange point back to your network, and maybe connectivity with an even more global view. It could be for public access, as many exchange points do, or it could just be member-only access. But again, having a looking glass means you can log in to something that sees what the peering at the exchange point looks like, and you can do troubleshooting there. Content distribution, caching, various providers offering content distribution services. Some of the broadcasters, other content providers love going to exchange points for reasons I was talking about before. Network time protocol, so you can locate a Stratum 1 source. GPS receiver, quite easy to get one of those, plug it in. Atomic clock, you can get those as well. Put it into the exchange point and make that as a time source available for members. Routing registry, to register the routers in a few places. So looking at the route collectors, I mentioned those way back early on. Usually a router or a Unix system running BGP gathers routing information from the service providers of the IX. So basically, each service provider, the exchange point, not only peers with the other members, they peer with this route collector. Right? Doesn't forward packets, doesn't announce prefixes. All it lets you do on the collector is see the BGP prefixes that the members are announcing to the exchange. So it just gives a public view of the routing information available. Very useful for publicizing what's at the exchange point. Very useful to try and attract local members, new members, saying, hey, look, we've got all these prospective members, can check how much traffic they have to those destinations, and they can see if it makes sense for them to join. Useful for troubleshooting purposes as well via looking glasses, as I mentioned before. And the collector just plugs in there. It's just another router plugging into the switch, everybody peers with it. So what can it be? Some people use a router, more commonly just a Linux system running BGP, running something like Bird. Tiny memory requirements, it only needs to carry the IXP routes, doesn't do any packet forwarding, it's just gathering prefixes. And it peers with every IXP member, accepts everything that the members announce, doesn't announce any prefix at all, doesn't need a public AS number because nobody sees it. It's only seen by the local members. And of course, there'll be a back-end connection to it, hooking it into a website so that somebody can connect to the website and operate looking glass commands to just do things like show BGP and so forth. So most of them will implement some form of collector, actually usually more as a route server. When, again, sophisticated requirements. You don't need some monster device just to collect routes. It could be run on a very, very simple appliance, as long as you're able to run BGP. Looking at route servers, has all the features of a collector, but what it also does, it will announce routes to the participating members. Some of the route servers can also put routing policy definitions in as well, but in the simplest case, it's literally everything I hear, I pass on to everybody else. As I said before, service providers with an open peering policy tend to peer with the route servers. So it's a very simple way of them being able to peer with all the members without having to contact each one to set up a direct BGP session. So features of these, again, it helps scale the route distribution. It doesn't forward packets. You know, some folks think the route server somehow has all the packets going through it. It doesn't. There's something in BGP called third-party next hop. Because the route server is on the same LAN, the next hop that the route server learns is actually used by the routers that hear the prefixes from the route server. So the traffic does not go through the server. It's only there to help pass on BGP prefixes. So this simplifies the routing process for the members. The members can just peer with the route server. They don't have to peer with anybody else. And every time there's a new member, they peer with the route server, and then they get all the other peers at the exchange point. Of course, I find quite often that people will peer with the route server, and then they'll set up bilateral peering across the exchange point as well. You know, they may wish to do that. So you end up having two BGP sessions, one with the route server to hear the peers' prefixes, and another one with the direct, probably for redundancy purposes, or they want to have the direct peering for other reasons. Its optional participation using the route server is not mandatory. It's there as a service to assist scaling BGP. If you use a traditional router, not a great idea because you end up with the route server autonomous system appearing in the AS path, which then can end up as physical distance. It looks at the AS path length, the number of AS hops between source and destination. So if your route server AS appears in the path, it ends up path length is going through your upstream provider. So don't use a traditional router. It's actually much better to use a router or BGP software that doesn't insert the route server AS in the path. So this is generally what your normal peering mesh would look like. It's n squared. So for a large exchange point, dozens of participants, it gets really, really cumbersome maintaining all the BGP sessions. Drawing every line like there on PowerPoint is a bit of a pain as well. So it's similarly hard to manage the BGP. So what the route server does, and this is the path of BGP announcements, we've got two route servers here in this IX. Each member will peer with the two route servers, which means you can take one out for maintenance and you don't affect the function of the exchange point. Right. So again, we're talking redundancy here. So this means you only have to have two BGP sessions, one with each route server. Of course, you can come along later and add in direct bilateral peering if you want to, but at least this is a nice, simple setup, so you don't have so much to manage for BGP. Right? Just to emphasize, the routing information flow follows the dotted lines there. Packets do not go through the route server. The traffic goes directly on the LAN between the two peers. They do not go through the route server. You know, I'm just emphasizing this so often because so many people say, oh, well, I need a really big device for the route server. And it's like, well, why? You're only carrying 500 prefixes from all the members. Oh, but it's got to carry all the traffic. No, it does not. The traffic does not go through the route server. So be very aware of that. So it's advantageous, certainly to get to large exchange points, because it helps scale the eBGP mesh, helps scale the prefix distribution. And it simplifies the BGP configuration management, as I mentioned already. Of course, if you have open peering policy, the route server is great. If you have selective peering policy, then you can lose direct policy control if you choose to peer with the route server. So it's only for those who have open peering policy, really. Because if you're selective, by definition of the name, you want to select who you peer with, and you can't really do that through the route server unless it has that functionality in it. And most try and keep it simple so it's a way of just distributing prefixes. And of course, I already mentioned the insertion of the route server AS in the path. So that's if you're using a router. So avoid using a router as the route server there. Right? Optional service. And as I said before, most exchanges will offer it as a service to the members. Right? So typically, ISPs will directly peer with significant peers, and then they use the route server for the rest. Right? So the route server implementations, Bird, pretty much the standard and works best. So that runs quite nicely on simple Linux or FreeBSD systems. There is Quagga as well. Quagga has more scaling issues, and I don't know if there's really much development work being done on Quagga as much. I mean, certainly folks I speak to generally say Bird, and there was one other one as well that was mentioned to me the other day, and I haven't put it in the slides here. But certainly folks are telling me Bird is pretty much the standard. If you use a router, well, Cisco actually introduced this route server client feature in iOS 15.2 and iOS XE 3.7. But if you know your Cisco routers and so forth, it's only on the ASR 1000 series. And you end up having to buy a fairly substantial box, both in price and physically, just to run a simple route server setup, which is a great shame. I would have much happier to see it on one of the very small Cisco router appliances. I mean, the ASR 1000 is a great router for many things, but I'm just disappointed that the route server function was only available in there. Be beneficial for your IX? I would invariably say yes. I tend to set them up right from the start in exchanges. It's helpful when BGP knowledge is limited, but it's not an excuse not to learn BGP. I've heard that one come up many times, like, oh, the community here doesn't know BGP, so we'll just run a route server and it'll all keep it simple. That's fine to get going, because peering is important, but it should not be an excuse not to learn BGP. Anyway, I think BGP is relatively simple. Plenty of workshops, plenty of training are out there, so it's not hard to get this set up. And of course, having a route server there means you don't have to maintain a large number of eBGP peers. So I've got a few slides about what can go wrong, and I'm sure this is not exhaustive. But this is stuff I've just accumulated over the years, trying, again, helping exchange points and helping exchange points getting started and so forth. So let's see. Some service providers attempt to cash in on the reputation of IXs. My internet transit service is an exchange point. We're exchanging packets. No. An internet exchange point has a very, very clear, well-known definition. Right? These layer 3 exchanges, the internet transit providers, a router is used. Most famous example, of course, is there on the screen. Not an exchange point. It's a transit provider. There are many others. I'm not going to name them, but there are many others. Financial can go badly wrong as well. Some of the exchanges price the IX out of the means of most providers. To be honest, Lynx was guilty of this at the start. I mean, the joining fee at Lynx was substantial. because what the initial members were trying to do was make sure that their customer, small boutique providers, let us say, couldn't join the links because they're our customers. We can't possibly have our customers going there. And then the regulator kind of got a little bit interested. Right? There's local peering. You want the little guys to peer with each other. You want the mid-sized guys to peer with each other. You want the big one. You want as many people as possible at your exchange point. Who cares if they don't all peer with each other? Get them all at the physical location, and you can potentially have very, very big impact in the local economy. The only acceptable charging model, in my opinion, is cost recovery. Recover your costs, nothing more. Some of them charge for port traffic, which is fair. You're competing with your members directly. And I honestly think if you compete with your members, you lose. Because if your members see that you're competing with them, they just unplug. So don't charge for port traffic. There's nothing wrong with charging differential prices for the different physical interfaces, because they cost money. But only do that if the members agree there should be differential pricing. As an IX operator, you don't want to impose this on anybody. You're there, you're serving your membership, right? Quite a few IXs forget it. You're serving the membership. The membership determines what happens. Dictating to your members means they go, right? Your exchange point won't work. You end up with somebody else setting an IX up down the street from you, and you lose. Too many exchange points in one locale. I'm not going to mention a certain large European country where there are loads of exchange points in one city. Because who do you end up having to connect to? All of them? Becomes very, very expensive trying to connect to all of them. So they don't or won't. Local traffic suffers, and it just defeats the whole point of having the exchange points in the first place. It's not a competition. It's not a profit-making business. You want as many people to come to it to interconnect, keeping as much local traffic local as you can. Try to compete with the membership, offering services that the ISPs would do. Right? In reality, the exchanges are operated by the members for the members. We've seen that happen quite a bit, trying to compete with the membership. It just doesn't work. Right? The members don't like being competed with. They're already competing with themselves. The last thing they want is an infrastructure operator competing with them. Run as a closed privileged club. I mean, I've talked about that earlier. Restrictive membership criteria. Oh, if they're all born in January, then they can join. But if you're February or March, no, you can't possibly join. I mentioned the links earlier. We had the very high entry fee, which had to go because it was basically seen as an anti-competitive, closed, privileged club. Right? In reality, a participant needs to have an AS number and their own independent address space. Some countries try and do, the exchange point's only for ISPs in this country. Well, that's fine. You're not going to get any business. Right? All exchanges need to be open to everybody without restriction. Have their own address space, own AS number, and their own transit. That's only requirements. Another one's very common, located in a data center with a restricted physical and transmission access. I mean, some parts of the world, unfortunately, we're really stuck about where we can put it. I can stand up here and say, oh yeah, neutral interconnect, neutral location. Many places don't have that. The economy is not developed enough to have that. So we need to try and find the best compromise that suits everybody. And some of the compromises have been really, the compromise, we have to do something. It's better to get packets flowing locally than go, oh no, this compromise is no good at all. Better get something going so that people see the benefits, and then we can try and find something that's better. But definitely, having restricted physical or transmission access just makes no sense at all. Charging for traffic, that's just insane. Transit providers charge for traffic as well. So that just finishes your IX. So end of discussion. Providing access to end users rather than just network operators and service providers. But again, it comes back to the exchange point needs to have their own address space, own AS number, and own transit arrangements. I mean, even if they buy transit from another exchange point member, they still need their own transit. You don't get transit through the IX. It's a local peering thing. And of course, trying to do what's called multi-homing with somebody else's address space, well, technically it works, but practically and operationally and business and legally, it doesn't happen. So you really do need to have your own address space. And of course, getting your own AS number from APNIC. And of course, the final one, interfering with member business decisions, mandatory multilateral peering. If all the members want this, great. They have it in Tanzania at the IX there. Never worked. Has come, no, goodbye, not going. So don't interfere with what the members do. Technical design, interconnected IXPs. Actually, there's one that I'm aware of that seems to work really well close by, but there's no real transit arrangement between the two. There's no real connection, I suppose community connection between the two. And it actually seems to work okay. But that's rare. The exception doesn't prove the rule. The exception doesn't make it will work for everybody else. But
which one?
That was in the border between Italy and France.
Lyon and Milan,
Milan, Lyon and Milan.
That's the Milan state government throwing tons of cash at it.
Yeah, so it's just for the benefit of the webcast. Oh, I can say it here. Yeah, that was Bill just saying it was a Milan state government providing lots of funding to interconnect the Milan and the Lyon exchanges. Is that right?
Yeah.
Yes. Yeah. But that's about the only one I know. But I've been living in Australia since, 1998, and every 2-3 years, up pops the, we need to interconnect all the exchange points in Asia. Right? Who's going to pay for it? How are you going to meter the traffic? Oh, the government's. What about all the other service providers who provide transit between all these regions? It's just the insane idea that pops up every 2 or 3 years. Right? It competes with the members. If you compete with the members, you're out, you're gone, you're finished. So metro interconnections, of course, work fine. People then throw this back at me and say, oh, well, how does links work? Well, I know links is in, 8, 9, 10 different locations around London. But links doesn't extend the LAN all the way down to Sydney in Australia. Well, hope they're not going to do that. Right? That sort of thing doesn't work. ISP bridge the exchange point LAN back to their offices. In some of my early years of helping getting well, of course the IX doesn't want the office LAN to appear. What was there? There was one exchange point I saw, it was window file shares and NetBIOS stuff and so forth because somebody had bridged it back. Oh no, honest, we've just got a router there. Well, I don't know if a router forwards layer 2 stuff. So financial benefits of connecting to an IX far outweigh the cost of a router. And of course, the usual thing, if people can't afford a router, what on earth are they actually doing? Routers you can have for like $100 from some of the really inexpensive providers. Right? So it can have disastrous consequences for the security, integrity, and reliability of the exchange point. Oh, routing design errors. Route server mandated. So we already talked about mandatory peering, no history of success. Service providers have no incentive to learn BGP, no incentive to understand peering relationships, peering policies, or anything else. So you become entirely dependent on the operator of the route server for troubleshooting, configuration, and reliability. Route server can't really be run by a committee. Remember, it's designed to assist with scaling the exchanges. So we put the route server in and invite people to use it if it makes sense for them to do so. And if they need training about BGP, there are 101 different BGP courses out there on the internet, even dealing with how to set up or connect to IXs. This is a classic one I've seen. Thankfully, it's all disappeared and people don't try and do this anymore. An iBGP route reflector. Oh, wow, none of the participants do BGP, so let's just run a route reflector on the IX and then their networks become part of my network. So I'm not even going to waste time on the slide. Just don't do it. I've had to help, well, I didn't help, but because the operator of the IX had to unravel this, but I still had to validate that the migration path made sense. it was really, really hard to unravel all this, right? Taking over other people's networks is not the way to run an exchange point. So what can go wrong? Summary, not a transit business, but just a layer 2 switch. If charging, fair cost recovery is what you want to do. It's not a competition. We're not competing with anybody. No rules apart from good behavior, no restrictions, no mandatory peering, no bureaucratic management, no interconnection with exchange points. By reference to bureaucratic management is some of the exchange point founding. We see people spend years and years and years setting up more and more complicated management layers and committees and subcommittees and side committees, and nobody's moving any packets. I much prefer to try and get packets moving between ISPs first, and then we get the lightweight member association up and running after that. The politics always takes a lot longer than actually doing the interconnects. Don't try interconnecting with other exchange points. You end up competing with members. Don't let people bridge the LAN back to the members. Right? Use a route server to try and scale the thing. So more information. I've collected URLs and various other things, and I'm sure it's not complete, but I'm giving it a go anyway. So acceptable use policy can be useful. So the minimum rules for connection. It's things like don't point default routes, locking down the ports a little bit, and so forth. Also fees, no fee or cost recovery. Some exchange points are commercial, but again, that's their choice, and that's what the participants have agreed to. It's fine. Nobody should be obliged to peer. Agreements are left to the actual service provider members. Right, so don't point default route. Be aware of third-party next hop. Only announce your aggregates. We've got RIPE 399, RIPE 532 for V4 and V6 best practice announcements. Filtering is very important. Filter the prefixes you get from other providers. Filter what you send to other providers. Just the standard good behavior. I don't even bother trying to list exchange points, but you go just around some of the major IXs around the world. Everybody's using Ethernet switches, of course. So some of the features, multiple switches. As we get bigger, UPS generator, you want good, reliable, long-term power. You want 24/7 support in the data center. DNS, route collector server, content caches, NTP. We've talked about all this before. Location, ideally neutral, secure, accessible co-location. Address space, public address for peering LAN, public address for any services there. AS numbers, so public AS number, probably for the route server. You need a public AS number for the exchange point services anyway. From the start, so traffic data, so the membership can actually see what's going on, and make it public as well. So you see the aggregate traffic running through the IX. IXP creation, this is a classic one, and some of you in the audience will totally get what this is about. No economy or circumstances unique or different, yet everybody tries to tell me, oh no, we're different here. Well, you're not different here. Everybody's different, but we're all the same. The first excuse is, we don't need one, because everything is working just fine. And then it's, once we've figured out, well, maybe we do need one, but it's different here. We have different ways of doing things. Of course, every locality has its differences. But surely every locality wants to keep local traffic local, improve network performance, QoS, improve the local internet economy. You want to have your own internet businesses. You want the round-trip times to be very low. You want internet access to be very cheap. Everybody wants that. So the technology is the same everywhere. And there really isn't any excuse for not improving the local internet. But gosh, we see plenty of those all the time. I don't know why there's such resistance in some parts of the world to creating exchange points. It just seems such an obvious thing to do, to make the local internet faster and better. Ecosystem development as well. Create the exchange point association formed by members who have a port at the exchange point. And of course the members meet regularly. Yes, the board will meet, but the board tends to be more the management folks. But what about the technical community? The technical community could also meet at the exchange point member meetings. Right? So that could lead to the creation of a network operators group. Many places don't have one. The technical community, the only time they get together is when there's some other type of meeting. So, and forming the basis of a NOG seems to make great sense to me. Now, the various industry associations, of course, I've mentioned EuroIX a lot. I had quite a bit to do with EuroIX when I was working at Cisco, because we were a patron of EuroIX. And of course, in our part of the world here, we have APIX, Asia Pacific Internet Exchange Association as well. And they have members from the Asia Pacific region, and Tiyama-san sitting at the back there, and he looks after APIX twice a year, conferences, so go and have a look at that. I'm sure the folks at APIX will be delighted to be involved in helping anybody here who's interested in exchange points as well. Documentation about how to get up and running. Of course, it's written from the European perspective, and of course, there'll be slight differences for here, but they form the fundamentals of what we do. Now, be aware one thing, telegeography lists ISP interconnect points. Don't fall into the trap of this being all internet exchange points. They're not all internet exchange points. But they are interconnect points, and many of them could be exchanges. Internet Society lists quite a few things as well. I mean, they're updating all this content, I hear, so be aware that this will probably change over coming time. So, I'm being chased on. IXP is a layer 2 infrastructure, at least 3 players required, of course, meeting in an open, neutral location. Minimal rules, minimal bureaucracy, cost recovery, encourage participation of all autonomous networks. It really does help develop the local internet ecosystem. So, minutes over. So I did start a couple of minutes late. So, anyway, I hope this was interesting, useful for you. If there are any questions, I'm happy to take questions now. Otherwise, I'll be around during lunch and the rest of the